Hey everyone, Mr. Andrew here. And we're going to be looking at these half life problems that were shared with you. So, we're going to work our way through each of these one by one. So, the first problem says thorium 231 has a half life of 25.5 hours. So, for this one, T 1 half is equal to 25.5 hours. If a 100 gram sample of thorium 231 is left out for 102 hours, how much sample will remain? So the first thing we got to find out is how many half-lives are taking place. So we know it's being left out for 102 hours. So we're going to take the total time it was left out, 102 hours, and we're going to divide that by the half-life time, 25.5 hours. And if we divide this out, we find that the answer we get is 4, meaning that 4 half-lives are taking place. So at this point, it's a pretty straightforward division problem because after every half-life, the sample is being reduced by 1/2. So if we start with 100 grams of sample, and we divide it by 2, we're going to have 50 grams of sample. This is 1 half-life. That 50 grams will get divided by 2 as well to be 25 grams. It's 2 half-lives. That 25 gram sample will be divided by half. That will be 12.5 grams. That's 3 half-lives. And that sample, 12.5 grams divided by 2, will be 6.25 grams. That's 4 half-lives. So after 4 half-lives, 6.25 grams remain. Okay. Let's look at the second one. A radioactive isotope started with a mass of 345 grams. What is the mass of the isotope remaining after 7 half-lives? So, there's kind of 2 ways to do this. One way to do this is to just divide this by 7, divide this by 2 7 times over and over and over and over and over again. And we can do that, okay? And in fact, let's do it that way, okay? At least at first, okay? And then after that, I'll show you a shortcut. So if we have 345 grams and we divide that by 2, that's going to be, get my handy dandy calculator out, 45 divided by 2, 172.5, okay? That's 1 half-life. 172.5 grams divided by 2, that's going to be 86.25 grams. That's 2 half-lives. 86.25 grams divided by 2, that's 43.125 grams. That's 3 half-lives. 43.125 grams divided by 2, it's 21.56 grams. That's 4 half-lives. 21.56 grams divided by 2, that's 10.6 0.78 grams. That's 5 half-lives. 10.78 divided by 2 equals 5.39 grams. That would be 6 half-lives, and 5.39 grams divided by 2 equals 2.70 grams. That's 7 half-lives. So 2.70 grams will remain. Okay. Okay, the third one. Thorium-234 has a half-life of 24 days. If 1 gram remains after 72 days, how many grams of thorium-234 were originally in the sample? So this is kind of a reverse half-life problem. Okay. Instead of losing, going forward in time, we're going backwards in time. But we're actually going to do the same thing. We're just going to change which operation we're doing. So similar to the first problem, if t to the 1/2 is 24 days, 72 days divided by 24 days, that's 3 half-lives. So if we start with 1.000 grams and we multiply it by 2, we're going to get 2.000 grams. Okay. So this is half-life 3, basically. That 2.000 grams times 2, that's 4.000 grams. That's half-life 2. And then that 4.000 grams times 2, that's 8.000 grams. That's half-life 1. So there was 8.000 grams originally. Okay. And the reason for that is if we start here at 8.000 grams, divided by 2 would get us to 4. That's 1 half-life. That 4 divided by 2 would get us to 2. That's 2 half-lives. And then that 2 divided by 2 would get us to 1. That would be the third half-life. Okay. So if we're starting with 1.000 grams, and it takes and we've gone through 3 half-lives, originally we have to have started with 8 grams. Okay, a 1,000-gram block of phosphorus-32, which has a half-life of 14.3 days. T to the 1/2 equals 14.3 days. Is stored for 85.8 days. At the end of this period, how much phosphorus remains? So this is kind of the same problem as the first one. We just have to do a little bit of math. 85.8 days divided by 14.3 days equals, let's make my 8 a little better. 85.8 divided by 14.3, that is 6 half-lives. Okay. So 1,000 divided by 2, that's 500 grams. That's 1 half-life. 500 grams divided by 2, that's 250 grams, 2 half-lives. 250 grams divided by 2, that's 125 grams. It's 3 half-lives. 125 grams divided by 2, that's 62.5 grams. It's 4 half-lives. 62.5 grams divided by 2. 31.25 grams. That's 5 half-lives. 31.25 divided by 2. That would be let's fix it. 15.625 grams. That's 6 half-lives. So 15.625 grams remain. Okay. Last one. The half-life of thorium-232 is 1.4 times 10 to the 10 years. If there are 12.5 grams of the sample left after 4.2 times 10 to the 10 years, how many grams were in the original sample? Okay, so got a little bit of a curveball in these ones. These years are in scientific notation, but we're still going to treat them kind of the same way because in actuality, this problem isn't that much harder as long as you know what you're doing. So 4.2 times 10 to the 10 years divided by 1.4 times 10 to the 10 years. So this is a huge number, and we don't want to type that into a calculator. But if we look carefully, because we have 10 to the 10 on the top and bottom, we can actually cancel that out. And so now it's just 4.2 divided by 1.4, which that will be 3 half-lives. So now, what seemed like a little bit of a challenging problem is actually pretty straightforward. 12.50 grams divided by 2, that's going to be 6.25 grams. That's 1 half-life. 6.25 grams divided by 2, that's going to be 3.125 grams. It's 2 half-lives. 3.125 grams divided by 2. That is 1.563 grams. That's 3 half-lives. So the answer is 1.563 grams. Oops. I made it oopsie. It says right here, how many grams were in the original sample? I actually have to go backwards. Yikes, that's embarrassing. Let's go ahead and fix all this up. Select annotations. I want to get rid of all of these. Delete those. That's the beautiful thing. That never happened. Shh, that didn't happen. Okay, so we actually are ending at 12.50 grams, and we want to go up. So 12.50 grams times 2 equals 25 grams of sample. That's the result of half-life 3. 25 grams times 2, that's 50 grams. That's the result of half-life 2. And 50 grams times 2 equals 100 grams. That's the result of half-life 1. So if we started at 100, one half-life would get us to 50, two half-lives would get us to 25, three half-lives would get us to 12.5. Okay, so the sample had 100 grams of thorium 232 originally.